Hi, this is Jacob Nash with JNGL, and today we are looking at, can I click? This is going to be Unit 5B, Lesson 3C. I've never had a C lesson, only A's and B's, but this time C, because this is kind of a very strange unit, because it just has lots of parts to it. So this is Lesson 3C. It's kind of building off of Lesson 3A and 3B, so you might want to watch those ones. And the one that is 3A, it's not labeled 3A because when I made it, I didn't know that I was going to do 3B and C. So it just says Lesson 3. So that's what you can do. But anyways, we're looking at some more triangle congruence theorems and postulates that can prove that triangles are congruent. And I already mentioned some of these on 3A, but I'm mentioning them again in more detail. Okay, so the first one is angle side angle postulate. And it has to be in that order. And why is because S is in the middle, that's the side, and it's going to be the included side. That I already told you what that, well, I told you what an included angle meant on lesson 3B, but included side is just, once again, in between the two angles, and I'll show you what that is. But the definition of this, that you don't necessarily have to memorize, so I'm not going to type it, but I'm going to say it. If two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, then the triangles are congruent. What that looks like is this. We have a triangle, we have one side, and then we have another triangle. This side is congruent, and you have these two sides that are congruent, these other ones, and the included side is the one that's in the middle. Can you notice that it's in between the two angles, this one and this one? So that's what that means. So that's what they would look like. Just by seeing that, you could tell these triangles are congruent. So that really is all there is to it. I mean, triangles can look in different ways, but that's how it is. We can go to a statement and reason proof system that was discussed on lesson 1, but I'm going to pause the video so I can get that ready. Okay, welcome back. Not sure if the screen, it may have froze and it might be on the thing that it was before I paused it, but sorry if that's the case. But now I have this table here, and hopefully it will switch over soon, if it hasn't already. But, let me just put this back here. So, I wasn't able to write down what's the given and prove, what you need to prove, but I'll say, let's say you need to prove that first, segment JL is congruent to LN, then that angle J and N are congruent, and let's see, that's it. That's the only things you need to, that are given, and you need to prove that triangle JKL and NLM are congruent. So remember, when we're doing these, you just need to prove that each statement, really each thing that you see on the visual, you just need to basically say it out. So what's in red, blue, and yellow, that's what you need to put in here. And in this case, what's in red and blue are already given, but you just need to talk about what the yellow is. But first, the first thing we need to do, and if you're like thinking like, oh, I'll go on this website and do things like that, well, that's just because I drew over it and then undid it. That's how I was able to make that work. But don't think that's a special feature on this website. It's not. And so that the reason that we say that is that it's given. So JL equals LM. That's what these blue markings mean. So we prove the blue. So let's just go ahead and put a blue check by this because we proved what was in blue. Now, sorry, I can't do that actually, because I'll have to push the undo button to do this. So, there. That's the next thing. Angle J and N are equal. That's what's given. That's what I already said was given. So that proves what's in the red. Now we need to prove what's in the yellow. You have to come up with that yourself because it's not given. Well, we find out that angle L equals angle L, and that's that thing that's really annoying. But it's true that these are both angle L's. Really, it's KLJ and NLM. But we can just say angle L because we already said angle J and N for that instead of, you know what I mean. But the reason why is because it's reflexive. Reflexive means it just says the same thing. That's why they're equal. But the other reason why is that they're vertical angles. And we know from Unit 2 that if there's vertical angles, which are the ones that are across from each other, they're always congruent. Last thing we need to say, since there's nothing else to prove, we proved each color, and now we need to just say what we had to prove, because now it's true, because we proved everything that we see. Triangle JLK is congruent to triangle NLM. That is, and the reason why, I told you before to say the reason is that it's proven, but it came across to me from a question that someone emailed me and asked. By the way, if you ever have a question, jacobnash747@gmail.com. But someone had a question and they were like, well, my teacher said that you don't say proven. It's just you say the reason, like that's a postulate or a theorem. Well, if that's the case, then we can put that there. But I'm pretty sure I did learn that way. And also, if you know, there's someone that's named Mr. Shives, and he explains that in his video. But whatever your teacher asks you to do, that's what you need to do. But you could say proven if that's what your teacher is fine with. But in this case, it's the angle side angle postulate. That's what I already said. All right. Well, that's it now. Now we're going to go on to our next, that's actually a theorem, because it's a little bit different. Let me find my eraser. It's up here. Okay. Alright. I don't know why it's gray. If it's eraser, it's supposed to be white. Okay. That's better. Alright. Next is the angle. Sorry. I need to make that bigger. Angle. Okay, too big now. Angle, side postulate. Or theorem, sorry. What this one says is if two angles in the non-included side of one triangle are congruent to two angles in the non-included side of another triangle, then the triangles are congruent. And notice that the S is to the side because it's not included. It's not in between the A's. And this is basically the same thing as the other one, except this time the angle can be not included, but the triangles can still be congruent. Here's what that looks like. We have two triangles. Let's just say we have one there, and then another one like this here. We have these sides that are congruent, but the angles aren't going to be outside of it. The side's not going to be included. So these are congruent. If we were using the angle side angle, then the other congruent angle would be there, but this time it's here because using this theorem, it's not going to be included, and it's not. You can see it's not in between them. If it was included, it would be right here, but it's not. So that's what it is, and we can tell just from looking at that there's congruent. But once again, it could look in lots of different ways. Of course, the triangles could be turned like this. They could be even together, or like in the other problem, it could look like this. Whatever way they're set up, you can tell. But once again, I'm going to pause the video for the next proof table, and we're going to try to figure it out. See you then. Okay, welcome back to this video, and I'm on a different site now because I thought that was better to do. So anyways, we're back with this table that we have to do, and what's given is that segment AB is congruent to CD, and well, that kind of say DC, but that's okay. And then angle B is congruent to angle D, BD. So, well, we can already see that. So, remember the things that we have to prove are these, and these. So, let me just, let's see, circle, so that the first, all the things that we need to prove. Let's see. So, we need to prove these red angles, that they're congruent. All we have to do to prove them is just say that they are congruent in the table. But then also these, and then also these, it looks like one, but it's really two angles, because if this is two triangles, then that's what it is. So those are the things we need to prove. But in the given, what's already proven is that the red, that they're parallel. These are parallel. That only can help us know why these yellow angles are congruent. But let's see in the table. So the first thing that we say is that what's given? Segment AB is parallel to CD. Given. Okay, now let's look at that. And the next thing is also given, that angle B is congruent to angle D. Now we've proven the red. Now we need to prove the yellow or the blue. It looks like we're going to prove the blue. Angle or line AC is equal to CA. That's reflexive because that's the same thing. But why we have to say that is because, like I've been saying a bunch of times, this is two triangles. It looks like it's just a parallelogram, but it really is two triangles put together. They're just that's the reason why we're proving that they're congruent, because they're two triangles. And then the next thing, so we just proved the blue because that's what that congruence mark meant. And now number 4 is that angle back BAC, so BAC, that's this, and DCA. So these yellow angles are congruent. Why? Because they're alternate interior angles. The only reason why that statement can be true is that in the given that these lines are parallel. If these lines weren't parallel, then the alternate interior rule would not work. So that's why it's important to have that. Because if we don't have that, then there's no way. Basically, if you didn't have the statement, then that means that this would be wrong. And if that's wrong, then the whole thing's wrong. That's the whole reason why we have to prove it, because we have to say every statement to make it true. We can't just say that. We can't just say, oh, they're congruent because they look like they are, and I see congruence markings. You have to describe them. Make sure that they're true. You have things to back it up. Evidence. The last thing is number 5, and that's that triangle ABC is equal to CDA. That's what we needed to prove. Remember, you can say proven if that's fine with your teacher, but you might need to say what the theorem is, and that's the angle side theorem. And that is exactly what it is. That's exactly how you do this. So thank you for watching, and I'll see you on lesson 4, because I know this time there won't be a 3D. So thanks for watching. If this doesn't make sense to you, there's descriptions about this table on lesson 1, and also more things about the theorems on lessons 1, or in lesson 2, and 3A and 3B. So thank you for watching.